All right, number 80 says, in a physics lab experiment, a spring clamped to the table shoots a 20-gram ball horizontally. When the spring is compressed 20 centimeters, the ball travels horizontally 5 meters and lands on the floor 1.5 meters below the point at which it left the spring. What is the spring constant? Okay, so we have some abbreviations we need to know the meaning to. According to the second equation of motion, which is what we need to use, we're going to plug in what we've been given, this information. So the distance the ball falls is going to be 1.7. It's going to equal the initial velocity, which is 0, times time plus 0.5, which is our, let's see, okay. Yeah, gravitational constant times 9.8 times time squared. So that's what it looks like so far. And then to figure out the time, it's going to equal the, if we isolate the t by itself, we get the square root of 1.7 divided by 4.9, which equals 0.589 seconds. So the horizontal velocity is going to equal v of x equals x over time. Since we have that now, we can plug that in. 5.1 divided by 0.589. That equals 8.66 meters per second. Okay. So then the kinetic energy is going to equal the potential energy. Let's make a separate section here in the stored spring. So KE is going to equal PE in this scenario. So we can go 1/2 times m times v of x squared equals 1/2 times k times delta x squared. Delta x squared. Okay. And then where delta x equals 19 meters is the compression of the spring. So we can go 20 times 10 to the negative third times, let's see, 8.66 squared equals k times 0.19 squared. And so the spring constant, when we isolate k, is going to equal 41.55 newtons per meter.